My name's Laura MacCaughey and I'm a postdoctoral research fellow at the University of Technology, Sydney. And tonight I'm going to talk to you about tackling the problem of antibiotic resistance. Imagine going back in time and talking to your great-granny or your great-granda and telling them that one day a simple pill could stop them dying from an infection. They wouldn't have believed you. To them, that idea would just have been too good to be true. Because back in your great-granny's day, the leading cause of death worldwide was infections. But this unbelievable idea did become reality in the 1940s when we discovered antibiotics. Unfortunately though, since then, we've forgotten firstly, how scary and deadly infections can be, and secondly, just how amazing antibiotics are. As devastating and horrifying as the current COVID-19 pandemic is, it has finally given me a platform and a captive audience to talk about my work and the problem of antibiotic resistance. Because sadly, we now all know, just like our great-granny did, how scary and deadly infections can be. The problem of antibiotic resistance is multifaceted. I could talk about it for 3 days, never mind 3 minutes. It involves things like misuse by humans, overuse in farming, pharmaceutical industries dropping out of development, and a lack of a global concerted effort to tackle the problem. But I don't have 3 days, so what I will say is that antibiotics are the cornerstone of modern medicine. Without them, we couldn't do things like routine surgeries, chemotherapy, organ transplants. Even something like getting a tattoo could be deemed too risky to undertake. And even if you have never taken antibiotics in your life, you can still be infected with bacteria that are resistant to antibiotics. So that essentially means antibiotic resistance can affect anyone of any age in any country, and that includes you. We're already well along the path towards returning to a pre-antibiotic era, like what your great-granny would have lived through, because antibiotics are no longer working against a huge range of bacteria. And this is because the bacteria are smart. They're constantly changing and evolving to be able to fight off the effects of the antibiotics. So to avoid over 10 million deaths a year, by the year 2050, we need to act now to tackle the problem of antibiotic resistance. And this is where I come in as a microbiologist. So my work looks at developing new antibiotics and identifying exactly how these antibiotics work. I've identified a protein antibiotic called piocinell-1, and I've solved its crystal structure, so I know exactly what it looks like. And that's really useful when you're developing new antibiotics. I've identified a component on the surface of bacteria that my piocin antibiotic binds to in order to gain entry into the bacterial cell. And I believe I've identified a component inside the bacteria that my piocin antibiotic may be acting on in order to kill the bacteria. But why is my work important? Well, if I can identify what piocinell-1 looks like, what it binds to on the surface of bacteria, and exactly how this piocin antibiotic kills the bacteria, then this will give us a new weapon to use in our fight to tackle the problem of antibiotic resistance. Thank you.